Hello and welcome to another video looking at the calculations in chemistry. The calculation we are tackling today is a reacting masses calculation, examples of which are coming up on the video now. When doing these calculations, it is important to note that there are all sorts of different ways that you could lay these out. Different teachers, different YouTube videos all have slightly different methodologies. What is important is what works best for you, and obviously what gets the right answer. I'm going to share with you the technique that I use in my classroom and hope that this will benefit you. For my students, if I have set this sheet as a homework, feel free to use this to check your answers, and more worksheets like this are available on our school's file store. And as always, feel free to pop into my classroom at lunch or break time for any extra help. If you can't find me, pop me an email. If you are not one of my students, hello and welcome to you. If you are a teacher, this resource and its associated worksheets are freely available on my TES shop. The key stages in this calculation are as follows. Read the question. If they have already given you an equation, use that. If they have not given you an equation, you will need to read and interpret the question to write your own. You must ensure that this chemical equation is balanced. Using information from the question, identify important bits, i.e. the chemicals that they want you to do the calculation for. Step 3. Calculate the required relative formula masses of those chemicals. Step 4 is slightly confusing on face value, however, if you actually have a go at it in an equation, it starts to make more sense. What you have to do is divide each relative formula mass by the relative formula mass of the chemical which you were given the mass of in the question. This is easier to understand once we have a go at a proper question. Step 5. Multiply each value by the known mass. Okay then, let's do this. What mass of magnesium oxide, so that's an important bit, I'm just going to circle that here. I'm just going to put a question mark there just to remind us that that's what we're trying to find out, is formed by the complete combustion of 6 grams of the magnesium. That's an important bit. Again, I'm just going to circle that and write down the 6 grams because I know the mass of that one. I know that 2 moles of magnesium will react to form 2 moles of magnesium oxide. I don't know the mass of the magnesium oxide, I do know the mass of the magnesium. 2 moles of magnesium will get you 2 moles of magnesium oxide, which is essentially a 1-to-1 relationship. Relative formula mass. Relative formula mass of magnesium is 24. Relative formula mass of magnesium oxide is going to be 24 plus the relative formula mass of the oxygen, which is 16, to give you a total of 40. The magnesium is the one that I know the original mass for. I know that in the question it states that I have 6 grams of magnesium, so I am going to use the relative formula mass of magnesium, which is 24. What I want to do is to get this as a simple ratio that it's easier to understand. So I'm going to try to simplify 24 down to 1, because then I'll have a 1 to whatever relationship. The way I get down from 24 to 1 is divide by 24. Whatever I do to one side, I must also do to the other. So I do the 40 divided by the 24, which would equal 1.6 recurring. At this point you can leave that on your calculator, you don't have to take that off, it saves you having to type it in later. Leave rounding as late as you possibly can. The original mass of the magnesium was 6 grams, so I'm going to do 1 times 6 is the 6 grams. Whatever I do to one side, I must do to the other. So I'm going to do the 1.6 recurring multiplied by the 6 grams is 9.9 grams recurring. Of magnesium oxide. I'm going to simplify this using the approximately equal sign to 10 grams. The answer to question 1b is on another video. Please click the link below.